All right, Brian, read us the objective, please. On 3, 1, 2, 3. So today we're back to polynomials, and we just need to revisit them before we get into equations using polynomials. So, the concept of polynomials in your Fourier model, right in there, polynomials in your Fourier model. Without looking at your notes, fill in your Fourier model. You should know by now the definition. You should know what they look like, what they don't look like, and at least a couple of hashtags. So, think back, try to see if you can retrieve it from your long-term memory, bring it up, think about it. And the definition is very simple, if you can recall. Very, very simple. Okay? Copy that, and I'll give you some time to think it through. Go. Give me a second. Let's see if yours looks like this. Yeah. Very good. Yeah, I thought it looked exactly. Very good. So yeah, polynomials are monomials, or sum of difference of monomials, and here are just some examples. Non-examples, and I'm pretty sure it's obvious why they're not polynomials. Tell your neighbor why they're not polynomials. Because they're equations, and polynomials, we're talking about expressions again, right? That's why it says here hashtag expressions only, hashtag various terms. You can add more hashtags if you want. All right. So you can finish this later. You have the notes. So steps. I'm not going to give you steps. You're going to come up with the steps. Okay? Bless you. So, but what I am going to clarify and elaborate more on is two factors. So on the, two terms, which is factors and factoring. On your Q column of your notes, do you guys see that little space you have on the left side? Yes? Write this down, please. Factors and factoring. On your Cornell notes, you should have a column on the left side empty, right? So you're going to write factors are numerical and variable expressions that multiply to get a product. Leave a space after that, and then you're going to write factoring, the process of finding factors of a number. Now, yesterday factors were just two numbers that multiplied, but that was for the purpose of yesterday. Today, now applying it to polynomials, this is the definition that I want you to remember. Numerical and variable expressions that multiply to give a product. Okay? Yes. So, let me elaborate on the definition. I'm going to start with numerical expressions that multiply. 2 times 23, Michael Jordan. Those two are factors because it's numerical expressions that multiply, yes? Here's another. 4 times 3x minus 1. These are what? Variable expressions that multiply. So here's one factor, here's another. Are we there? Now let me elaborate on factoring. Okay, here it goes. The process of finding factors. If I gave you the number, look up please, if I gave you the number 6, and I ask you for a factor, what would be one of those factors? Charlie. One factor. 2. Thank you. Does everybody agree that 2 is one of those factors? Yes. So, if I was tasked on call someone else, I would ask not to give me the next factor, but what process would you use to give me the other factor? Tell your neighbor, what process would you use to give me the other factor? Philip, go. Let's see. 2 times 6, does that give us the other factor? Close. What would be the other process? Axel. Division. 6 divided by 2 is 3. Does that give me the other factor? Yes. So what can we conclude? That factoring is dividing. Factoring is the same thing as dividing. So whenever you hear me say, we're going to be factoring, what am I saying? Dividing. Are we there? All right, underneath your third model, copy this. Example 1A. Factor each polynomial and check your answer. 2x squared minus 4. Example 1A says factor each polynomial, check your answer. 2x squared minus 4. Just copy it, and then I'm going to go over this one. All right, here we go. Writing utensils down, look up to the screen. All right, here it goes. For this example, I'm going to do a think aloud. Here we go. So I'm going to talk to myself. So I don't want any answers, please. Keep that to yourself as you're thinking them through. So here you go. According to last night's home play, they didn't give me anything like this, but they gave me something like this by itself and like this by itself. And they asked me to find the GCF and LCM. Okay. So, by looking at it like that, what number or what factor divides evenly into both terms? That is 2. Now I just need to find my other factor. To find my other factor, I know a process on how to find my other factor. That process is called factoring, which is also dividing. Therefore, 2x squared divided by 2 is x squared. Negative 4 divided by 2 is negative 2. This one and this one are my factors. Copy that, please. Okay, here we go. So now, every year, guys, when we get to this lesson or these lessons, I have students that still might not be completely clear as to what we're doing, and usually they just copy whatever I'm writing because they just want to take the notes and make sure that they study it at home. But every year, I have students that go home and all of a sudden, oh man, I don't remember, or you might have doubts about some of those problems. And I tell students, when we get to these, when in doubt, factor out. When in doubt, factor out. That's why that was the purpose of yesterday's lesson. Here we go, watch. I'm going to do that process for those of you that still need that extra help. Here it goes. Factor out. What does that mean? If I give you an expression, and here we go, I'm going to do a think aloud again. Okay. So, I'm going to factor this out like I did in last night's home play. So this is 2 times x times x. This one is negative 1 times 2 times 2. What do both of these have in common? They have a 2. And that is my GCF. Okay. What's left over on the first term? X squared. How about on the second term? Negative 2. Copy that, please. All right, here we go. So, Did we factor the polynomial? Yes. But now they're asking us to check our answer, like always, right? So I'm back here. Look up, please. To check, all I have to do is the inverse of what I did to get these. What did I do to get these? I divided. So what is the inverse? Multiply. Let's see. 2 times x squared, 2x squared, 2 times negative 2, negative 4. Did I end up with what I started? Yes. And that's how you check. So if you have two factors that are not right, when you multiply them, guess what? You're going to see the mistake. Does that make sense? Yes, Mr. Q, we love these. All right, good. How we doing? Some of the fingers all come through the yard so far? Got some 5s, 4s, 3s, 5, 4, 3s, okay? Here we go. Copy this one, example 1B. You don't have to copy the instructions, just copy the polynomial. Example 1B says, factor each polynomial, check your answer. Negative 14x minus 12x squared. Bless you. Negative 14x minus 12x squared. So let's do this one together. So, I'm going to think aloud, but now I want answers. Here it goes. So, according to last night's home plate, this is one number, this is another. Yes. What number divides evenly into both terms? 2. Very close? Negative 2. Okay. What else does each term have in common? 1x. That is correct. So according to my calculations, that's my GCF. So let's see. Let's find the other factor. So we're going to divide by negative 2x. So what is negative 14x divided by negative 2x? 7. What is negative 12x squared divided by negative 2x? Positive 6x. That is correct. And if you don't see it, factor it out. Yes? All right. And if we multiply these, we'll get the same thing. Yes? Let's double check. This is negative 14x. This is negative 12x squared. Did we get the same? Yes. So, steps. Okay, you can give me step number 1. Francesca. Find, okay, give me a specific term instead of just saying all that. GCF, there you go. Find the GCF. For step 2, what did we do with the GCF? Step 2. Leave. Divide the expression by the GCF. Step 3. Let's see. We found the GCF. We divide it. What do we do? Bless you. Kelly. Write your factors. Remember, we're not in equation, we're in expressions, right? So this is my first factor, this is my second factor. And what is step 4, everyone? Check. And how do we check? We multiply. That is correct. Very simple. Does that make sense? Yes, the process? All right. Shall we kick it up a notch? Here we go. Copy this one. Example 1C. Let's see how you do. Be nice. Example 1C, copy this. 8x cubed minus 4x squared minus 16x. Do that one by yourself. Ready, go. Who can give us the GCF? Go ahead, Christine. 4. Is that the GCF? It's close. Jemilette. 4x. Hands if you agree with that. That is correct. (8x cubed divided by 4x is 2x squared. Negative 4x squared divided by 4x is negative 1x. Negative 16x divided by 4x is negative 4. Hands if you got that. Okay, good. This is one factor. This whole thing is my second factor. Label that, please, so that you start distinguishing one from the others. Because later on, I see people writing, and I ask them, what are my factors? And all of a sudden, they start circling this one, this one, this one. No. How many factors do we have here? 2 factors. Are we there? All right, copy this one. Example 1D. Let's see how you do with this one. No? It doesn't work? Okay. Yes? Yeah. Okay, hold on. Negative 4 divided by 4 is 1. X squared divided by x is x. But whenever it's like this, sometimes we don't write the 1. Is that correct? Let's see. X squared, hold on. X squared divided by x. Let's see. Same base. What happens to the exponents? Once again, if you're having a little bit of, yes, factor it out, please. It doesn't help you? It should. Look, let me go back to the previous one. Look up. Yes. This is 2 times 2 times 2 times x, x, x. This is negative 1 times 2 times 2 times x, x. This is negative 2 times 2 times 2 times 2, negative 1 times 2 times 2 times x. So, Jocelyn, look at it. What do all 3 terms have in common? 2 2's, and then 1x, okay? So, if we do the 2 2's and 1x, 2 2's and 1x, what do we have left here? 2x squared, right? Negative 1x, and negative 4 on this one. Yeah? Yeah, like I said, you can check like that. All right, this one, example 1D, GCF. Everyone? 1. That is correct. 1. 3x cubed plus 2x squared minus 10 times 1. That's my GCF. Yes?
So why can't we just leave it as it is? Write it out again.
I want you to start extracting the 1 because we're going to get to some problems that you need to find at least the 1 as a factor for some of them. Okay? Here we go. So far, so good?
Yeah.
Copy this one. Example 1E. 8x to the 4th plus 4x cubed minus 2x squared. All right, check with the neighbor, see what they got. All right, let's see. What is our GCF, Matthew?
I got 2x squared.
2x squared. Hands if you got that. That is correct. So, we're left with 4x squared plus 2x minus 1. Hands if you got that. Good, okay. Let me give you a challenge one. Example, mega Q. Here we go. Ready? 72x squared y to the 5th minus 9x to the 4th y squared minus 3x y plus 3x y to the 5th. Remember, when it's... No, I was thinking something else.
Sure. I got it.
Damn. Be nice. Express. To get us started, who can give me the GCF? GCF. No, I know, I said to get us started. 10. 3xy. Hands if you got that. Now, who saw, look up to the screen, who saw now the pattern that when it involves variables, you go with the smallest degree? Who saw that?
Yeah.
Yes? Okay, good. So, who can give me the second factor? The second factor. Caleb.
Okay. How is it wrong? 24x y to the 4th plus negative 3x to the 3rd y plus negative 1 plus 1.
Hands if you got that? That is correct. Yeah, you could have, some of you left it with minus, right?
Yeah.
Yeah, that's fine. Either way is correct, okay? And the last one, here we go. Example 2. Yeah, I know, you don't have to copy the whole thing, but follow along. Here it goes, it says, the area of the court for a game of squash is 9x squared plus 6x meters squared. Factor this polynomial, listen to the instructions, to find the possible expression for the dimensions of the court. So I want you to draw this picture. And let's write the area inside, 9x squared plus 6x. We need to factor that. Therefore, what is the first factor? Everyone. 3x. So with that, can we find the other dimension?
Yes.
What are my other dimensions?
3x plus 2.
3x plus 2. So the dimensions of this court is 3x times 3x plus 2 meters. No, just meters. Okay. Our home plate for tonight is only pages 523 to 525 and 529. And number 529 only is numbers 1 through 7. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.